Now, often the constant of integration can be solved based on particular parameters or things within an experiment. This is a little bit easier to see within physics. In our class, we'll skip some of the physics applications and not really worry about those. But actually, we can look at this example, I think. But I kind of avoided it back in the first couple chapters because we didn't have a ton of time to get into those applications. We want to focus on business economics and writing equations and so forth. But anyways, it says find the antiderivative of 2x plus 3 with respect to x. Again, this is how we read it, given that capital F of 1 is equal to negative 5. And remember, as I said before, if we're talking about derivatives and antiderivatives, f prime we call the derivative of, can't see that. F prime is the derivative of x, and how our book does it is we call capital F the antiderivative of x. So remember that the derivative of the antiderivative returns the original, and the antiderivative of the derivative returns the original as well. Meaning, this is antiderivative, derivative, and there's the flow of, differentiation versus integration. And again, this helps me remember how to organize these, what these things mean. But basically, that's what this is saying. But first, before we are able to use this, we need to figure out what is capital F. What is the antiderivative? So it's sort of like, well, this would be f of x, capital F of x, because this is assumed to be lowercase f of x. And again, it doesn't have to be lowercase f of x. That's just the generic way of writing them as our book does the notation. So, well, the antiderivative function... well, again, we could just use our rules for antidifferentiation. So the antiderivative of 2x would be x squared. And the antiderivative of 3 would just be 3x. And of course, remember that since this is what we call an indefinite integral, we need to add c to this. And so, we can figure out our antiderivative function just by using the rules that we've been talking about in the last few class periods. But again, notice one of the things that might annoy you about this is, well, what is c? It stands for any number. And again, we can figure out c if we have enough information to do so, because technically this function has an infinite number of antiderivatives, whether it be plus 3 or plus 100, all of those make sense. But if we're given what we call initial conditions, meaning that f of 0 is something or f of 1, basically the antiderivative evaluates to be something very specific at a particular point in time, we could actually plug in 1. And what this is telling us is that capital F of 1 is equal to negative 5, sort of like a starting point. And if we were to plug this in, f of 1, well, that would change this to 1 and change this to 1, because that's what x means, right? F of x is defined by those x's over there. And again, this would be plus c. C is not, I would not plug into c though, because that's a different variable. But what it's saying is, well, that's what f of 1 would be. It would be 1 plus 3 plus c. So this would be 4 plus c. And what it's saying is that f of 1 is equal to negative 5, based on, that's exactly what this says. So if I plug in negative 5 in for f of 1, and I just plug into 1 into my antiderivative, I would get an expression which c is the only unknown left, because basically it told me x and it told me f of x. So there's 3 unknowns in this, f of x, and c. I could solve c from here. And if I subtract 4 from both sides, this would give me negative 9 is equal to c, and I could solve this more specifically. And then, I could clarify and write, well, okay, actually f of x is equal to x squared plus 3x minus 9. And this would finish my antiderivative. And also, this might be a little bit more satisfying because it doesn't have a c in it. C is a little bit not annoying or awkward. Those are not the right words, but it's not known. And actually knowing it as a number can be more comforting, because now I know exactly what this is. This is a parabola. I know exactly where it's at, and I could graph this, study it, and figure out the properties now that there is no longer an unknown value. And again, obviously, this is called an antiderivative function. If we take the derivative, we'd get 2x plus 3, 0. And so we can see that this is one of the antiderivative functions of the original. Again, it's just one specific answer based on those conditions.